In the previous lessons, we learned how to solve quadratic equations of these two forms, ax squared plus bx plus c equals 0, and ax squared plus bx equals 0. Today, we are going to learn how to solve a third kind of quadratic equation, one that is of the form ax squared plus c equals 0. So in other words, you only have the term that has an x squared and the constant term. An example of this kind of equation is negative 3x squared plus 12 equals 0. And in this case, your a is just negative 3 and c is just positive 12. We can solve this quadratic equation using the quadratic formula. We can also solve this quadratic equation using the factorization method. But because the form is so simple, the variable can be isolated using your basic processes of isolating variables, the one that involves undoing operations. Do you remember when you solve simple one-step or two-step equations and you undo operations in equations by doing the order of operations in reverse? That one. Recall that when we simplify expressions or equations, we simplify expressions, parts of the expression or the equation that are in groups first, or in brackets or parentheses, and then we simplify exponents. Then we perform multiplication or division, whichever comes first. Then we perform addition or subtraction, whichever comes first. The reverse order is just naturally, it's just doing it backwards. So let's isolate the variable in this equation by undoing operations. So we are going to undo the plus 12 first. And to undo plus, we do the opposite operation, which is minus. So minus 12 on both sides. We get negative 3x squared is equal to negative 12. So now we are left with negative 3x squared equals negative 12. To undo times or to undo multiplication, we use division. So we divide both sides by negative 3. That gives us x squared is equal to positive 4. So now we are left with x squared equals 4, and the opposite of squaring is getting the square root. So to undo the exponent 2 there, we get the square root of both sides of the equation. So we get x here, and the square root of 4 is 2. But there's something that we need to remember here. When we talked about exponents earlier this year, when we get the square root of a number, we said that there's technically two square roots. Usually when you're asked to give the square root of a number, we just give the positive square root. But technically, there's also the negative square root. So technically, the square root of 4, as we said before, is actually positive 2 or negative 2. Or you could write that as x is equal to positive 2 and x is equal to negative 2. And that's because positive 2, when you square it, it's equal to 4. And negative 2 is also positive 4 when you square it. Now notice that just like all of the other quadratic equations that we solved so far, this equation also has two answers. And remember that the special word, the special name for answers when you're solving an equation is solutions. So this equation has two solutions, positive 2 and negative 2. And just to check if our answer is correct, let's say that x is equal to, let's check if x equals 2 satisfies the equation. So if x is equal to 2, our equation negative 3 becomes negative 3. So negative 3x squared, that becomes negative 3 times 2 squared plus 12. Is that equal to 0? Let's see. So negative 3 times 4 plus 12, is that equal to 0? Negative 12 plus 12 is indeed equal to 0. Now let's check it with negative 2. When x equals negative 2, the equation becomes negative 3 times negative 2 squared, so that's your negative 3x squared, plus 12. Is that equal to 0? Simplify. Negative 2 squared is 4, plus 12. This is negative 12 plus 12. This will also give you 0. And let's take another example. 4x squared minus 36 is equal to 0. So we are going to undo the minus 36 first. To undo it, we plus 36 on both sides. Add 36 on both sides. So we get 4x squared is equal to 36. So we have 4 times x squared equals 36. We undo times or multiplication by dividing both sides by 4. So this gets eliminated. And so we have x squared is equal to 9. Then we undo square by getting the square root of both sides. And so x is equal to 9. And don't forget your plus minus 9, which means that x is positive 9 or x is negative 9. So two solutions. Two answers or two solutions, 9 and negative 9. Another example, this is slightly different because first, the right-hand side is not 0, but that's not going to be a problem. And the coefficient of x squared is 1. That's also not going to be a problem. That's actually making things a little bit easier. So first, let's undo. Again, we're isolating the variable x, so let's undo minus 1 first by adding 1 on both sides of the equation. So we get x squared is equal to 16. Then we undo squaring by getting the square root of both sides. So we get plus minus square root of 16 is 4. So again, that just means two solutions, x equals positive 4 or x equals negative 4. Another example, x squared plus 5 equals 41. So we subtract 5 from both sides of the equation. So we get x squared is equal to 41 minus 5 is 36. Next, we get the square root of both sides. We get x is equal to plus minus square root of 36 is 6. So again, it means two solutions, x equals positive 6 or x equals negative 6. Next example, 5x squared minus 3 equals 12. So let's undo minus 3 first by adding 3 to both sides of the equation. So we get 5x squared, this cancels out, equals 15. Then we divide both sides by 5. So we get x squared is equal to 3. Then we get the square root of both sides. You get the square root of both sides will give you x is equal to. Now here, notice that 3 is not a perfect square. So when you don't have a calculator, you can just leave it as it is. You can just leave it as it is, but don't forget that it must have a plus or minus root 3. Okay? But if you have a calculator, you want to see around the, because this is going to be a non-terminating decimal. So as a decimal, what would be the approximate value? So using the calculator, let's see. So using the calculator, The answer is the square root of 3 is about 1.73 in 2 decimal places. So that's plus minus 1.73. And I'm going to use the approximately equal to symbol here. So in this case, you can express your answer as just square root plus minus square root of 3. Or if you want to use your calculator and get the approximate decimal equivalent of the square root of 3, and in this case, it's plus or minus positive or negative 1.73. So when the plus or minus square root of 3 here is actually, that's what we call as the exact value of x. And 1.73 is the approximate value of x. And it's approximate value because we know that the square root of 3, because 3 is not a perfect square, the square root is a non-terminating decimal. And if we round it off, in this case, to 2 decimal places, then what we have, 1.73, is the approximate value of square root of 3. Let's have another example. So x squared plus 9 is equal to 14. Let's undo plus 9 by subtracting 9, doing the opposite operation. Subtract 9 from both sides of the equation, so we get x squared is equal to 14 minus 9 is 5. Then we undo the square by getting the square root of both sides of the equation. So we get x is equal to, so again, we have another case here of getting the square root of a number that's not a perfect square. 5 is not a perfect square. So this is a non-terminating decimal. So if you don't have a calculator, you can just keep your answer as plus minus root 5. But if you have a calculator, you can express it. You can get the approximate value. And let's say that we get the approximate value of the square root of 5. It's about 2.24 in 2 decimal places. 2.24 in 2 decimal places. So again, don't forget your plus minus. And this is called the exact value of x, or values. And these are plus minus positive or negative 2.24 is the approximate value, or are the approximate values of x in this equation.